Welcome to that of the PG students for the Great Question Solution 2024. Now we are going to that of the first problem regarding the photochemistry related problems. In the photochemistry related problems, here the Norris type 1 produces the CO cleavaging and get the radicals, and after the cleavage of the CO bond it produces the carbon monoxide and the biradical pieces, and then this biradical pieces undergoes addition to produce the cyclopentane ring. We know that the BBr3 is the iterative agent and produces the hydroxyl group which undergoes intramolecular addition to produces the lactone derivative. So the option A is the correct option. Now we are going to that of the next problem. Among the following compound the chiral compound is. We know that the chiral compound must have avoid the all type of the symmetry, that is the sigma I SN symmetry. If we see that of the molecules on the P compound, where if we convert it into that of the Newman projection, after the seeing from that side, we get a compound which contain the sigma symmetry. So it is the achiral compound. If we see that of the Q compound, after the Q compound, if we see on that side, after the conversion to that of the Newman projection, we see that a compound which has no plane of symmetry, only the C2 symmetry is present, so it is the dissymmetric molecule, but it is optically active. And this is the cumulative triene systems. We know that the cumulative triene system, after the this is the just like that of the alkene system, and so the whole molecule is planar and it contains the molecular plane of symmetry, so it is optically inactive compound. And if we compound that of the Spiro compound, after the conversion to that of the Newman projection, it produces the plane of symmetry and it is also optically inactive. So the option Q is the correct, that is this is the optically active molecule. Now going to that of the mass spectroscopic problem, so that is the phenol in presence of the sodium hydroxide carbon dioxide produces the Kolbe-Smith reaction and gives that of the salicylic acid as the product. And if the salicylic acid on treatment with that of the bromine water produces the 2,4,6-tribromo-phenol compound after the decarboxylation reactions. And we see that here the 3 bromine atom present on the aromatic ring, and if we know that the bromine atom contain the 2 isotopes, one is the 79, another is the 81, and it is present as the 1:1 abundance in nature. So the phenolic compound, the bromine contain, if the mass is m with the all the bromine atom contain the 79 isotope, and after that one contain that of the 81, another 2 is the 71, then this becomes m plus 2, and the probability for the existence of this m plus 2 ratio is the 3. And if we see that of the 2 bromine atom present in the 81 ratio, then it converted to that of the m plus 4, and it is also probability is the 3 existence. And in case of the all the bromine atom is the 81, then the mass is the m plus 6, so the probability in the 1. So the ratio can be is the intensity ratio of the mass for m plus 2, m plus 4 and m plus 6 is the 1:3:3:1. If we can also calculate it from that of the molecular formula A plus B to the power n, where A, B represented the abundance natures of the isotopes, and the n is the number of atoms present on the isotopic or present in the molecules. Here the bromine atom, 3 bromine atom present, so if we put that of the in the equation A plus B whole cube, and from this equation we can easily calculate that the ratio is that 1:3:3:1. We know that the resolution of the alcohol can also take place by the chemical methods or in the enzymatics methods. In the chemical method, we know that the phthalic anhydride used for the separation of the R or S isomers from that of the RS mixtures. Enzymes can also do the same problem, solve the same problem by the Candid Antarctica lipase enzymes. It specifically bind the one isomer and another isomer can be separated easily. If we see that of the RS mixtures of this isomer on vinyl acetate in presence of Canadian Antarctica lipase enzymes, it basically bind the one isomer, that is the R isomer is bind, and the S isomer can be separated from the reaction mixtures, and after hydrolysis we can also R isomer can be separated. So the option A is the correct. Now this is the examples of the Favorsky rearrangement problem. The reactions, the yield of the X as the major product is or are. In presence of the X, it produces it can be formed by the Favorsky rearrangement in presence of the sodium methoxide. At first the carbanion is formed, and then this carbanion produces the cycloketone intermediate, and both the substrate produces the cyclic ketone intermediate, that is the cyclopropanone intermediate, which can break to produces the desired after the desired product. So the option A, B is the correct option. In case of the C option, the dibulk can only reduces the ester to aldehyde, only it has only hydride donor, so the alpha, that is the cinnamaldehyde is the product. And in case of the hydrogen palladium calcium carbonate quinoline, it only the reduce the triple bond to double bond, but that is the cinnamate is the product. That is the given problem is not coincide for the option C and D. The reaction on that yield 2-methyl quinoline as the major product. That is, this is the problem for the quinoline synthesis. If we see that in case of the 2-aminobenzaldehyde undergo EG dimerization to produces the cyclic compound, or it can undergo after the imine formation, it can also produces the quinoline derivative. This is the side product. Most of the cases the dimeric product is obtained. In case of the anilines, if we treated with that of the butynyl aldehyde, 2-butynyl aldehydes, and after the conjugated addition in presence of the paratoluene sulfonic acid, and after the elimination of the water molecule and the DDQ is used, DDQ means dichlorodicyanobenzoquinone, it can be used for the aromatization, and it produces the 2-methyl quinoline derivatives. And if we see that of the methyl lithium with dichloromethane, it produces the carbene derivatives, and it only produces the 3-methyl quinoline derivatives. And this is the isatine, which on presence of the NOH after the hydrolysis it gives the compound, which an imine formation followed by isomerization and decarboxylation, we get that of the 2-methyl quinoline derivative. So the option B and D is the correct option. Next is the borax on treatment with NOH and H2O to form X. The compound X on reaction with PHCN means benzonidine at 60 degrees centigrade methanol water gives Y as the major product. We know that the cyanobenzene produces in presence of the H3 plus, it gives that of the carboxylic acid, but in presence of the hydrogen peroxide, it only produces the benzamide. That is the carboxylic acid is not formed. That is the benzamide is the intermediate for the preparation of the hydrolysis of the benzocyanide. In case of the this is the reaction means borax. Borax means Na2B4O7 on treatment with NOH and hydrogen peroxide, it produces the peroxoborate. This peroxoborate is the catalyst which can hydrolyze the benzocyanide, that is cyanobenzene, to benzamide. So the option C is the correct option. This is the problem for the organometallic reactions. Here the Wilkinson catalyst is this is the intermediate of the Wilkinson catalyst, and the Wilkinson catalyst after the elimination of the chlorine, it produces the after the addition of the CO group, it produces the desired intermediate of the Griffin problem, and which can attack to that of the alkene, and after the CO insertion, always the carbonyl group is inserted less in the side to that of the molecules, and we get that of the carbonyl addition product to that of the less inner sides, and after that the elimination of the hydrogen, addition of the hydrogen would get that of the butyraldehyde. This is the hydroformylation reactions of the Wilkinson catalyst. In case of the Wilkinson catalyst, we also prepare for the Grubbs 1 generation catalyst, and this is the precursor for the carbene generation of the cyclopropene derivatives, which react with that of the Wilkinson catalyst, produces the metallocarbene derivatives, and these metallocarbene derivatives is used for the Grubbs metathesis reactions, and hence this is the Grubbs 1 first generation catalyst. So the option A is the correct. Now this is the problem for the NMR spectroscopy problem. In the consider the following 1H NMR data of a compound delta 3.85 singlet 6H means it is the methoxy compound, that is the 2-methoxy group is present, and 6.73 J equal to 2.2 Hertz and 7.1 J equal to 2.1 Hertz, and this is the main criteria of solving of this problem, that is the coupling constant is very small, means that this is the meta coupling occurs between the two adjacent proton. Meta coupling occurs, that is the ortho coupling is not occur as the coupling constant is very minimum. So the option B is the correct. Here the option means the carboxyl group adjacent protons resonate at 7.1 and it is appear as a doublet, and the coupling constant, that is the doublet is appear due to the meta coupling, and the methoxy proton appear as 6.73. It is the shielded proton compared to that of the adjacent carboxylic proton, as the due to methoxy group is the electron rich proton. So the coupling constant is also appear as a triplet, and J equal to 2.2 Hertz and 1H. And the option A option is also contain the triplet and doublet, but the appear as this is the 1H triplet and this is the doublet for 2H. And other problem is not adjacent, that is the it contain the 3 types of protons. It also contain that of the 3 type proton on the aromatic region, and the green problem contain only the 2 type of proton in the aromatic region. So the option B is the correct. Now if we convert the Fisher projection of the D-fructose is given below, if we converted the Fisher projection to that of the Haworth representation, and we see that this hydroxyl group is in the upside, so this is the conversion of the beta D-fructofuranose, and with the hydroxyl group changes from the up to down, then it converted to that of the alpha, that is the below side, means the hydroxyl group present in the below side means this is the alpha. If we take the mirror image and we get that of the alpha L-fructofuranose, and the option B is the correct. Thank you for the watching the video.